Today's topic is units and measurements. Under this unit, we will talk about the physical units, the need for the prefixes, what are the least counts and the errors, and other measurement instruments such as vernier calipers, traveling microscope, micrometer, screw gauge, weight measuring instrument, and tire measuring instruments. Learning about these things definitely help you for the rest of your academics as well as for your career as well. When we talk about the physical units, the main idea of having a physical unit is to facilitate communication of scientific information. For that, there are several systems has been introduced throughout the history. Nowadays, we are using the SI system, or this international system of units, right? Also known as the system international units. Here for the SI units, for example, they have given standard dimension or standard unit of measurement for each and every physical unit. Okay, for example, if I take the length, right? If I take the dimension of the length, as per the SI units, the SI unit for the length is meters, right? And when you talk about the units, actually, there are two types of quantities. One is called as a scalar quantity, and the other one is the vector quantity. Scalar quantity, the difference between these two is that scalar quantities have a magnitude, but it doesn't have a specific direction. For example, the mass, volume, temperature, energy, pressure, and time. However, you can compare it with the vector quantities. They have both the magnitude as well as a specific direction. For example, displacement, force, velocity, and acceleration. You might learn these things in your O levels that vector quantities have a specific direction, right? And these are the main dimension or the base dimensions, and they are standard SI units, right? With their abbreviations. For example, length, time. Length is given by meters. Time is measured through seconds. Simple S. Mass is measured by kilograms. Temperature is the theta term. Theta is measured through capital K Kelvin. The electricity current, capital I, by through amperes. Amount of substance, capital N, by the mole, abbreviated as the MOL. The luminous intensity by J, measured through the unit candela. Okay. Apart from these base units, if you take 2 or 3 base units and connect it to equation, you can derive another unit, right? So these are the derived units, right? It's a combination of base units. For example, now how do you write down the equation for the speed? Speed is distance divided by the time, right? Distance divided by the time. So now the derived unit through the SI with the combination of SI units are meters per second, right? ms minus 1, or you can write it down like this, just ms. Frequency is given by hertz, right? Can combine it with the SI base units, 1 divided by the time. And third one is the force, right? Force measured through newtons, but Newton, the base unit is going to be kilograms. M is minus 2, which means force equation is F is equal to MA, right? F is equal to MA. M means the mass, which means it is in kilograms. And here the simple A means the acceleration, right? Acceleration is measured through ms minus 2, right? So that is how this unit has been derived. So like that, you can see others as well. Once you completely go through this SFT module, you will learn about these things by heart, right? You will use all these, each and every derived unit in your A levels for each and every example. So you don't have to worry about that. And I need to talk about some prefixes as well, right? Why we need prefixes? It is a letter or a group of letters that can be added to the beginning of a word to change its meaning, right? And the other, one important part is that when we apply this prefix to a word, is to avoid adding or removing any letters. For example, you can see the metric prefixes, right? For example, I'll take one SI unit, the meters, okay? So these are the prefixes. Prefixes can be added in front of any unit, okay? So if I take another simple M in front of the meters, what happened? It is called as the millimeters, right? It is called as the millimeters, right? Or if I take the mu term, right? The mu term, in the second example here, mu can be written down like this as well, right? Millimeters, micrometers, and nanometers, nm, picometers, pm, femtometers, fm, like that, right? So these are several prefixes, and there's another set of prefixes like this. So milli is backed up by what? Milli can be, again, if I take centi for that, it changes its meaning, right? And centi can be again divided into kilometers, right? And like that. So you can see this K, C, simple M. This is not meters, it is milli. See prefix, nano, pico, femto, like that. These are prefixes, right? Which means that if I add this milli term, it automatically take this 10 to the power 3 as a multiplication to that same value, so that the value is going to change, right? The meaning of the value is going to change. And these are the same things I have explained earlier. Here you can see starting from the simplest one, millimeters, micrometers. This is the symbol for micro, actually. It is 10 to the power minus 6. Milli means 10 to the power minus 3. Nano means, you can see the connection, the difference is by 3, right? 3 plus 3 is 6. 3, 6 plus 3, 9, like that. But however, in the latter case, if you go up milli to centi, it is 10 to the power minus 2. Decimeters, 10 to the power minus 1. And kilometers means meters and kilometers. What is the connection? 1 kilometer is equal to 1,000 meters, right? So that is why it is 10 to the power 3. Megameters is not a term actually, but when it comes to other units, for example, if I take the joules, right? Joules is also the dimension. We can use the joules to measure the energy, right? It may be heat energy or electrical energy, kinematic energy, potential energy, anything. The joule can be written down as one of the using the one of the prefix kilojoules, megajoules, like that. Okay. And what else? Um, and you might very commonly heard about these terms actually when it comes to the size of a data packet. Byte, kilobyte, megabytes, gigabyte, terabyte, petabytes, like that. So that is also one use of these. You can use any kind of unit and apply these prefixes, but that should be suitable. Okay, not everyone is suitable. Putting up, for example, let's say if I have the unit of um, let's say, let's take the volt, right? Capital V volt. So volt, I cannot say teravolt, right? Kilovolt I can say, megavolt I can say, giga. I mean, there's there might be limited. That values might be limited somehow, right? For example, amperes also, kiloamperes, megaamperes. We don't go for like gigaamperes, but it is always limited in milliamperes, microamperes in that scale. Okay, so each and every unit have its own limitations. Now, since we talk about several of these the physical units actually, now it's time to talk about the measuring instrument, right? Measurement instrument. We can use the measurement instrument to take the dimensions, right? Take the dimensions. If I want to measure a length, I can use a meter ruler, right? Like that. Okay. And the main idea of a measurement instrument is to take off the values in more accurate and with a higher accuracy as well as higher quality, right? For example, if I have like, let's say if I have uh, a pen tube, right? Let's say if I have a very small thread like this, very small one, very small diameter, right? And if I ask someone to measure the what is the diameter of this pen tube, right? You might think that I can use a meter ruler, which means that 50 centimeter or 100 centimeter meter ruler to measure this kind of a small value, right? Now it is not suitable, right? Using that kind of a large scale to make such a small measurement, and even we sometimes we cannot measure it to the exact value, right? For example, let's say this is the enlarged case of a pen tube. Okay, so this is the pen tube, this is the outer diameter and the inner diameter. Now it is a remember, this is an enlarged figure, okay, enlarged drawing. So if I put a meter scale near to that, adjacent to that, let's say 1, 2, 3, 4, 5, right? Meter ruler measurements might be starting from somewhere here and next one in here and next one in here, right? Let's say if this is 0, this is 1, and this is 2. 2. These are what is the least count? What is the least measurement we can take from a meter ruler? It is 1 millimeter, right? Okay. So here we have 1 millimeter, 2 units actually, but there's a problem. What is the problem? Now, if I put 0 scale starting from this part of the pen tube, second unit is going somewhere in here. First one is going somewhere in here, right? Now you cannot say, now you know the measurement is more than 1 millimeters. The diameter of this pen tube is, outer diameter of this pen tube is more than 1 millimeter, but it is not 2 millimeters. How you are going to specifically say this is going to be how much? Now, in some cases, you might say, okay, this is 1.5 meter. How you can prove that? How you can exactly prove this is 1.5 millimeters? Because there is no unit called here, there's no subunits, right? There's no subunit like this standing here, but you are assuming the value. Now you cannot do that with the industrial measuring instruments or industrial applications. We cannot say by just thinking about, okay, this is like in between, this should be 1.5. We cannot say like that. In that case, I have to say, you can see the value given by this meter ruler, it is not accurate, right? That is a problem. The quality of the measurement is not enough. Either, so in that case, either someone can say this is 1 plus or minus, right? 1 plus or minus 1 millimeter, right? Which means it may be the actually yeah, we cannot say this one as well, right? It is not going to be 0 millimeters, you know. So I have to delete that, which means the meter ruler cannot be used in this case, right? You can see the practical example of less accuracy coming from this instrument, meter ruler. So in this kind of a case, we can use a micrometer screw gauge where they have like more scales, which means the least count of that instrument is very much larger. You can measure it up to, here it is only 1 millimeter, you know, for the meter ruler, the least count 1 millimeter. But for the micrometer screw gauge, if you use that scale, it is up to 0.01 millimeters, right? So which means 1 millimeter again divided to 100 units. 100 units. So it is much accurate. So let's talk about in detail for the measuring instrument, right? I think you get the idea, which means that we cannot use same meter ruler for every measurement now, right? Okay. And in laboratories, so in industrial applications, either we can take the direct readings from a measuring scale, right? Either we can just collect the direct readings. Give me one example. Give me one example. For example, let's say, okay, you want to measure the length of this eraser, okay? You want to measure the length of the eraser. You can just take a, meter ruler, put the 0 in here, and find the distance up to this point, right? So this is called as a direct reading. But let's say this is only limited to the meter ruler, okay? But if you are using a micrometer, screw gauge, vernier caliper, or any other equipments, sometimes those instrument, due to higher use over the time, their mechanical part may be wear off. So in that case, what happened? There might be some errors with the measuring instrument. For example, for the meter ruler as well, you can see not the plastic ones. Meter rulers made out of stainless steel. Meter rulers made out of stainless steel, right? Okay, let's say that meter ruler can be used in two different temperatures. Let's say we are using that in Australia. So it is around, let's say 21 degrees. In the 21 degrees, let's say in the 21 degrees Celsius, if you are using the same meter ruler, the distance is exactly same. It is manufactured in Australia. So let's say it is 30 centimeter meter ruler. But if you are using that one in Sri Lankan countries, let's say in 30 Celsius, what happened there? Due to the heat, the meter ruler has expanded, right? Now what happened? The distance of a meter ruler has somewhat increased. Let's say, even though it is 30 centimeters, with that expansion of linear expansion of that meter ruler, it become 30 centimeters, now become 30 centimeters point 20 or 13.2 centimeters. Now there's error, right? If you are using that in to measure anything in Sri Lanka, you are taking a risk. You are taking the wrong reading. So in that case, there's another way of measuring scale. We can manually calculate it, which means the indirect reading, which means we casually take the, first of all, we'll casually take the reading, the reading, right? Let's say the length of this eraser is 2.5 centimeters, right? This is the normal measurement. Now we know there's a 0.2 centimeter error, right? So it is a plus error. To get rid of the plus error, we had to reduce it by 0.2 centimeters. So now the correct value, the indirect manually calculated reading is going to be 3.3 centimeters, right? So that is one example. And because of that, it is very important whenever you are using a measuring instrument, first of all, check the least count, which means what is the least measurement, the smallest measurement you can measure using that equipment. For a meter ruler, it is 1 millimeter. You cannot measure 0.5 millimeters using a meter ruler, right? And is there any errors? Is there any errors? Okay. Even though we have not concern about those errors, even though we are using the meter rulers, we are not considering about these things. But when it comes to industries, we need the precision values, right? Precision readings. Otherwise, the manufactured part might not be coincided, right? They are not be fixed. Okay, that is one important thing to remember. Moving on, what is least count? The least count of an instrument is the smallest measurement that can be taken accurately with it. Okay. Here you can see the meter ruler. What is the least? If I use consider the millimeter scale and not the inches scale here, what is the least value I can take out? The gap between one and another small line, right? Let me use another color. Let's say this is 4 millimeters, and adjacent to the 4 millimeters, what is the inter? What is the smallest unit? Distance is 1 millimeter, right? And for the inches, it is also the same, right? If you take distance between these two lines, that is the least count of the inches scale of a meter ruler. But as commonly we say it is millimeters, right?